Okay, imagine a world that suddenly runs out of the one thing it absolutely needs to survive. Not oil, not water, not gold. I'm talking about a resource so fundamentally baked into our existence that civilizations simply cannot operate without it. Yet, almost nobody can even name it. In this explainer, we're going to trace the path of an invisible, irreplaceable element. We'll look at the geopolitical chokepoint that controls it, the terrifying preview we've already had of what happens when it gets scarce, and the incredibly bizarre place where the ultimate solution is hiding.
Usually, when we think of global shortages, it's something happening out there, right? In a distant mine, or an oil field, or some dried-up reservoir. But this shortage, it is deeply, intensely personal. There's an element inside your body right at this very moment. It's working constantly. Without it, you wouldn't just be less healthy. You literally would not exist. And the stark reality here is that as a planet, we are rapidly running out of the easily accessible reserves of this exact element.
Okay, let's dive into this because to understand the stakes, we have to look exactly at where this element lives. And this isn't just some abstract chemistry lesson. This element is the structural backbone of your DNA. It's the very genetic code that makes you, you. It builds the membrane around every single cell in your body. And honestly, maybe most incredibly, it is the core component of ATP, which is basically the microscopic battery that powers every cell you have. Every breath, every thought, every single movement you make is powered by this. Nothing on Earth has ever found a biological workaround for it. No element, no life. It really is that simple.
So, what is it? Well, it's phosphorus, element number 15 on the periodic table. Now, pure phosphorus is actually this pale, waxy rock that is so reactive it literally catches fire in open air. And its history? Just as wild as its biology. Centuries ago, an alchemist first isolated this element not by digging in the ground, but by, wait for it, boiling down buckets of human urine until he found something that glowed in the dark. He actually thought he had discovered the philosopher's stone. But what he had really stumbled upon was a fundamental gear in the machinery of life.
All right, let's zoom out from the microscopic cells in your body to the dinner table and look at a fundamental rule of agriculture. It's called the law of the limiting factor. A plant needs three main things from the soil to grow: nitrogen, potassium, and phosphorus. You take any one of those away and the crop fails. You can have all the water and sunlight in the world, but your plants will only grow as much as the scarcest nutrient allows. Last century, we actually learned to mine phosphorus by the mountain and spread it across fields as synthetic fertilizer. That sparked the Green Revolution. Crop yields multiplied and the Earth's population absolutely exploded to 8 billion. Today, researchers estimate that roughly half the people alive right now are fed by food grown with mined synthetic fertilizer.
So, the crucial point is, there is no substitute. I really want you to let that phrase sink in, because it is the entire spine of this issue. When we talk about running low on oil, sure, it's concerning, but we have solar, we have wind, we have nuclear, we have backups. When we run low on phosphorus, we have nothing. You cannot synthesize it in the laboratory. You can't invent a cheaper alternative. There is no plan B element waiting on the shelf to take its place. What is in the ground is exactly what we have to work with.
And this brilliantly illustrates our next problem. Where actually is this remaining rock? When you look at global oil reserves, they're relatively spread out across multiple continents, right? Not phosphorus. The overwhelming majority of the world's remaining phosphate rock reserves, by most estimates around 70%, sit under a single nation, Morocco. The element that every single human being on Earth needs to eat, and a single kingdom controls almost 3/4 of what is left. It is a terrifying geographical choke point. And it gets even more complicated when we look at the map a little closer. A very large share of that phosphate rock actually lies in Western Sahara. Now, this is a territory whose status is actively disputed. It's claimed by people who state that the vital rock under their land is being mined and sold without their consent. So the supply chain that quite literally feeds the planet doesn't just run through one highly concentrated area, part of it runs through one of the longest-running territorial disputes in the world, which adds a profound layer of political fragility to our entire global food supply.
Now, if you're wondering what happens when a fragile supply chain like that gets rattled, the year 2008 gave us our answer. In the span of just a few months, the price of phosphate rock didn't just tick upward, it detonated. It skyrocketed by roughly 800%.
2008 was essentially our global dress rehearsal for a true phosphorus shortage. When the price of the rock exploded, fertilizer suddenly became completely unaffordable for farmers around the world. And as we know, fertilizer prices don't just stay on the farm. They travel straight to the grocery store. We saw global food prices spike abruptly. In country after country, the cost of a basic meal jumped way beyond what average families could pay. And we know what happens when people can't afford bread. Upheaval, massive protests, and unrest swept across multiple nations. It was a 90-day preview of what running out actually feels like, and it was chaotic.
Now, eventually in 2008, prices fell back down and the system steadied. That was a wobble, not the wall, but it left us with a very quiet warning. Experts fiercely debate exactly when we're going to hit the absolute wall of depletion. Some argue we have centuries of rock left, while others warn that the cheap, easy-to-reach, high-grade deposits will start thinning out within decades. But almost all of them agree on one terrifying reality. The price moves long before the rock is gone. We aren't going to wake up one Tuesday to find zero phosphorus left. Instead, we're going to feel it as a slow, grinding economic squeeze on the basic cost of feeding ourselves.
Let's move to and see how this builds into an almost tragic irony. Because we can't make more of it, we have to ask, where does the phosphorus we currently use actually go? Well, we mine it from the earth, mostly from that one fragile corner of the globe. We spread it by the ton onto our agricultural fields. We harvest the crops and eat it on our plates. And then, well, because nearly all the phosphorus that passes through your body leaves your body, we flush it straight down the drain.
We are literally flushing it away. But it's actually worse than that, because we waste it twice. The first waste is from our cities and our own bodies. The second waste happens on the farm. You see, a huge share of the phosphorus we pour onto fields never feeds a single plant. Instead, rain washes it off the soil and pushes it into our rivers. And when it hits the water, it does exactly what it does best. It makes things grow. It feeds toxic green algae blooms that explode across the surface, choking off oxygen and creating massive ocean dead zones where almost nothing can live. We take the most vital element for human survival, treat it as garbage, and just let it poison our waterways.
Now, what's really interesting about this slide is this is where the narrative pivots. There is a fundamental rule of chemistry working in our favor here. Phosphorus is never destroyed. You can't burn it up like a tank of gasoline. Every single atom of phosphorus we have ever mined out of the earth is still here on the planet. It's just scattered. It's in the soil, it's in the rivers, and it's in our wastewater. And because it's still here, that means it can be caught.
So we're looking at a massive paradigm shift. The old model relied entirely on mining finite rock from the earth, using it once and then losing it to the environment. It's a completely destructive, linear path with a hard expiration date. But the sustainable model changes the game completely. Instead of mining rocks from a pit in the ground, modern engineering is allowing us to mine phosphorus directly from municipal sewage. We are literally shifting from a model of depletion to a model of recovery.
So how exactly do we do that? And listen, this isn't science fiction. This is technology running today. Modern cities can actually act like massive nutrient mines. First, treatment plants capture the urban wastewater and sewage that we produce every day. Then, using advanced reactors, engineers trigger a chemical process that forces the dissolved phosphorus to crystallize. They literally grow clean, pale crystals of a mineral called struvite right there in the treatment plant. Finally, this pure struvite mineral is packaged up and returned directly back to the farm to be used as high-quality fertilizer. We are quite literally mining the toilet to grow our food.
It's just this profound, almost cosmic irony. The single most irreplaceable resource on Earth, the key to preventing global starvation and the solution to a looming geological crisis, has been sitting right beneath our cities the entire time. Every single day, humanity has been flushing away the very element we desperately need to survive. But by capturing and crystallizing it, we turn our own waste into a deeply powerful, sustainable loop.
So the real crisis we face isn't just that the rock is running out. The crisis is that we've spent decades throwing away the one thing we can't replace. We know the sustainable solution. We know exactly how to recover these vital nutrients from our wastewater. The question staring us down now is simple. Will we invest in and scale this technology globally before the easy rock is gone and the next massive price squeeze hits? Next time you look at a plate of food, remember element 15. It's holding up everything, and its future is entirely in our hands. Thanks for joining me on this explainer, and keep questioning how our world really works.